Hello and welcome to Team 11's Telecom Customer Churn Prediction Project for OPIM 5671. Included in our presentation will be details on our dataset, a discussion on each of our models, the final results, and why we chose our final model, and applications for the business. Utility companies borrow to invest in fixed assets, then fund their operations with cash generated from those assets. To grow, they need to expand the number of customers. Customer retention is the key to success. The overarching goal of telecom carriers is to grow the customer base, to add new customers while keeping the old ones. Disconnects can slow the expansion of a company's customer base or even hurt it, which hurts the company's financials. The company wants to add customers faster than the rate they are being lost. The objective of each telecom company is to maximize customer additions and minimize churn. Customers may churn for a number of reasons, including canceling contracts, non-renewals, switching carriers, or simply terminating service, and even sometimes due to death. But all customers are not the same, and some are more worthy than others. In our sample, the propensity to quit was split, with short and long tenures having the highest probability of churning. Long tenure customers are more profitable. The question being asked is, how could a telecom company possibly minimize their churn, and what customers should they go after? In the telecom industry, carriers try to retain their customers to maximize profits. Carriers have expanded beyond traditional voice services into broadband data services, internet security services, and streaming TV to lock in customers. With a broad range of communication services, carriers have multiple touch points with the customer. Generally, the longer a customer stays with the carrier, the more services they will buy. With the low incremental costs for adding customers and services to the network, carriers have incentive to add as many customers and as many services per customer as possible. Carriers compete by service offerings and have a broad range of communication services. Verizon and AT&T have bought companies and adjacent communications businesses like television, social media, and cloud services. With broader offerings, hanging on to the current base is critical. Customers buy more services over time, and so these high-profit customers are tough to replace. In this analysis, our group tries to assess why they would decide to churn by correlating variables. The data was gathered from a telecom churn analysis on the website Kaggle. Uploaded 2 years ago, the raw data contains 20 columns, 7,043 rows, and there are 11 missing values of the raw data, which were omitted in the analysis. Now onto the modeling section of the presentation.
Okay. After importing the data, we made changes to metadata configuration. Well, the left picture shows the statistics for our target in the dataset. Our dependent variable churn is binary. So no means the customer did not churn, and yes means the customer did churn. As we can see from the picture, about a quarter of the dataset churned and 3/4 stay with the carrier. So to get closer to the reality, we decided to adjust the prior probabilities to reflect the 5% rate of churn. As we know, customers choose to churn will lower the revenues, and intervention to avoid churn will have customer service costs. So we are looking for ways to lower the expenses so that we can maximize profit and minimize loss for a carrier. Well, as we can see from the right picture, we adjust the decision weights to reflect the cost of churn and added these details to the confusion matrix. Our decision 1 is to intervene with a customer service call, which will generate an expense of $50. Decision 2 is not to intervene, so there's no expense. We also assume a subscriber who churns will not generate any revenues per month, and a subscriber that stays with will generate like $100 in revenues per month. Well, there are 3 continuous variables in our dataset, which are monthly charges, total charges, and tenure with a carrier. And during the data exploring, we found only total charges had 11 missing values. The total charges represented the contract value at the time of execution. Since we did not have the start date or the completion date or the date of the survey, so missing values in this column are irrelevant. And before the modeling part, we did the chi-square test. The chi-square plot shows that in addition to these three variables, multiple lines, phone service, and gender, the other variables have a high correlation with the target variables, indicating that the other variables may affect the customer's final decision. So here are the models we have chosen, which are logistic regression, gradient boosting, decision tree, autoneural, and neural network. And before we do the logistic regression, it can be seen from the data exploration that the distributions of only three continuous variables in the dataset are all seriously biased distributions, and the standard deviation for these three variables are large. So to make them look better, we tried using Noctem, which improved the distribution, and we also tried optimal binding, which made the distribution look more normal. And in order to facilitate the subsequent model comparison, the misclassification is used as the main criterion for evaluating gradient boosting, decision tree, and neural network. So let's move on to the next part.
Now we have already established 5 classification models here. The next step is to make model comparison and choose our best one. So from the enterprise perspective, managers always want to figure out whether our models could make profit. So at first, we choose the average profit and loss as our first criteria. As it shows from the result table here, we can see that our regression model has the best result with over $24 average profit. And the neural network also did a good job. Obviously, our models could bring business values for telecom carriers. Then we also compare the ROC and lift. From the ROC curve, we can see that all our 5 models almost have the same result. From the left chart, when considering 10% of our observations, our lift is up to the 3.5 for our regression models. It is really a good enhancement. On top of that, we also check the confusion matrix. Because we think just depending on the average profit and loss criteria is not enough. The cost and the profit structure of an company will vary from time to time. So we need to check confusion matrix to measure our model's predictive ability. As you can see here from the confusion matrix, our regression model again has the best result with best accuracy 81% and best sensitivity 53%. Finally, not like the neural network, we found that our logistic regression model is easy to explain. From the parameter and the coefficient estimation table here, we are easily to realize that a long-term contract and a long tenure will definitely decrease the possibility for our customers to churn. It makes sense because these long-term factors will increase our customers' stickiness. So based on these good insights, we can make more well-informed strategies for our clients. So we choose our regression model as our final models. Next, let's move to the application and the recommendation part.
We took a look at the business of tech to understand what the competitive pressures were and how the different players in tech could use our churn predictor. So we looked at the top 12 companies in tech, and we focused in on the mid-size one because we thought that they could benefit the most from the churn predictor. So in looking at how they could, where they should focus, we found that the 80-20 rule applies, that 80% of the revenues come from 20% of the customers. And so we took a look at the transformations that we did for total charges in the optimal binning. And then we took another look at changing those to log 10. And we found when we changed them to log 10, we could identify the top spending customers. They were on the right-hand side of the axis. And we found that if we kept the optimal binning as it was, it would give us the highest frequency of customers, which were sometimes the very low, which were more often than not the low-paying customers. So we decided to focus on the high-end customers that were generating the most in revenues. And then we also took a look at monthly charges to understand how the revenues work. We found that there was a spike at $25 or less a month, and then there was a normal curve. So we wanted to capture the customers that were at the right-hand side of the continuum. And we looked at the tenure, and we found that that was bifurcated. There were two spikes. One was less than 6 months, and the other was more than 60 months. So we decided we wanted to focus on the customers that had longer tenure because they, number one, spent more, and number two, had more loyalty. Then we also took a look at the ways that the different companies are, telecom and tech companies are growing and what that means. So they're growing through acquisitions, and Verizon added a search business for Yahoo for $5 billion a couple of years ago, and AT&T added Time Warner in the television content area for $85 billion. So we wanted to understand how they make sure that those acquisitions are successful. So we took a look at what the valuations are for these companies and how the players that buy them decide what they're worth. And we decided that it could be all over the place. Yahoo actually turned down an offer to buy Google for $1 million in 1998. We know Google's worth more than $1 million now. And then Yahoo offered $3 billion for Google only 4 years later. And then Google countered at $5 billion, and Yahoo said no. So that still wasn't very bright for Yahoo. No wonder they're getting taken out. And then Microsoft offered $40 billion for Yahoo in 2008. And Verizon ended up winning the prize for $5 billion 8 years later. So we found that the most important variable for these companies was actually whether they could hang on to the customers and then continue to grow the revenues per customer. And AT&T, we looked at them, and we found that when they bought Time Warner a couple of years ago, the price actually for Time Warner went up, but the price for AT&T went down. So that meant that maybe they paid too much, or maybe the investors don't think they can hang on to the customer base. But either way, we thought they needed some help in understanding how to keep their customer base. So going forward, the next big battleground is going to be the Internet of Things. And that's virtual reality, augmented reality, robots, and driverless cars. So all of those different things are going to be loaded onto the network, and your mobile network is actually going to be steering your car. So we want to make sure that we understood who the valuable customers were, so we could help different companies that are getting into these new businesses understand how to keep their customer base, how to grow services over time, and how to compete with their existing networks. Thank you.